All right, so I want to go through a few examples on this video and also on the next video, just to go through a few more kinds of problems that you would use arithmetic sequences to help you solve, or using the definition of an arithmetic sequence to help you solve that. So the first one says the sum of the first, and there will be two, like the two warm-up problems here that we'll look at this on this video. So it says the sum of the first 8 terms of an arithmetic sequence is 156. The sum of the first 14 is 483. What is the starting term of the sequence? So if I think about like just kind of organizing that into a mathematical equation. So the sum of the first 8 terms. So you've got like term 1, term 2, all the way up to the 8th term. And since it's arithmetic, we can construct a summation. It's the first term plus the last term times the number of numbers. So there would have been 8 divided by 2, and it tells us that sum is equal to 156. Now you could divide the 8 by 2 to get 4. So we have the first term plus the 8th term times 4 equals 156. And then if you want to divide the 156 by 4 to get 39. So we know that the first term plus the 8th term is equal to 39. But the thing is that 8th term is not really useful. I like the first term, but the 8th term not so much. So what I'm going to do is I'm going to rewrite that 8th term as using its definition, because any term, remember in an arithmetic sequence, any term can always be represented as the first term plus n minus 1 of the differences. So since the 8th term would be 7 differences, I could say that's the first term plus 7 differences. And so now what I'm setting myself up for is a system of equations when I get the second piece of information. So it's just in terms of the first term and the number of differences. So I can combine this. So this is 2 of the first terms plus 7 differences equals 39. So that's going to be my first equation. Now, next equation, the sum of the first 14. So again, the first term, second term, all the way up to the 14th term. I could write that as the first term plus the last term times the number of numbers over 2. And it tells me it's equal to 483. And just like last time, I can divide this out. So I get the first term plus the 14th term times 7 is equal to 483. And then we can divide that 7 across to get 69. So first term plus the 14th term. And then, just like last time, that 14th term is not as helpful as rewriting the 14th term as the first term plus 13 of the differences. So then I have a second equation here, 2a1 plus 13 differences equals 69. That equation and the first equation can now be solved simultaneously. So I'm going to go, since 13 is bigger than 7, I should say, I'm going to put that one on top. So 2a1 plus 13 of the differences, and then 2a1 plus 7 of the differences. And then I'm going to subtract. Don't forget to subtract the quantity. So the a's cancel. 13 minus 7, so I get 6 differences. And then 69 minus 39 is 30. So my common difference, my skip, is equal to 5. And as soon as I find that, I can sub that into, maybe this equation, doesn't really matter, and solve. So now, that's green color. So 2 of the first terms plus 7 of the differences, which we just found as 5, is equal to 39. That's a 35. Subtract that over. So 39 minus 35 is 4. So our first term is 2. So it says, what is the starting term of the sequence? Oh, well, then that's nice. It's 2. So using that summation was useful, but then rewriting the last term as the first term plus n minus 1, the differences. Okay, now the second warm-up example it says, suppose the sum of the first 15 terms is equal to 330. So we're going to do the exact same. Setup. So the first term, which would be A1, plus the last term, which is A15, times the number of numbers, 15 over 2, is equal to 330. And so 15 divided by 2 is 7.5. But then what I'm going to do is rewrite the 15th term, since I kind of already know how this is going to go. That 15th term is the first term plus 14 differences, okay, times that 7.5 is equal to 330. Now, 330 should be divisible by 7.5, since this, you're just adding up, integers, whole numbers, right? So that's 44. So I know that that's equal to 44 if I divide that 7.5 over. And A1 plus A1, so that's 2A1 plus 14 differences equals 44. Now, in the last example, we had another equation, another set of data. In this example, we do not. So there must be something else to this problem. And we're trying to find just a term, right? Just the 8th term, which might seem a little arbitrary, like why not the first term, or why not the sequence itself? And so then, maybe also you're noticing in your equation, you can divide by 2. So A1 plus 7 differences is equal to 22. And then again, thinking about that 8th term. Well, when we looked at the 8th term in lots of different examples, or what's another way to write that 8th term? Remember, the 8th term can always be written as the first term plus 7 differences. And so this problem, kind of was cleverly written that's right there. Like, even though we don't know what A1 or D is, the way that it's arranged, we know the exact center term, which would equal 22. So we're actually done. So, and again, we talked about this, that when you have an odd number of terms that you're adding up, so your first one, your last one, your second one, second to last, right? So everyone pairs up, right? When we do this first, last, the next to next, next to next. But then there's always if there's an odd number, there's always one in the middle, which always represents half of the sum. And so that's why this works out. We can only find the 8th term, and that's it. No matter, there's no other terms we can find. But the other kind of cool thing is that any arithmetic sequence that you have that has 22 as the middle term, there are multiple sequences you can come up with that could have a sum of 330, and all of them would always have 22 as the central point, which is really cool. Okay, I think maybe I'll just do this example here on this video, and then there's a few more homework examples that I want to do on the next video. So this one, number 3, just to kind of remind yourself, finding the value of k. So the overall terms are not arithmetic, right? Because 4/7 to -5/9 to 6/11 to -7/13, the overall terms themselves are not arithmetic. But there is some pattern to the numerators, and there is some pattern to the denominators. So if you just focus on the numerators for 5, -5, 6, -7, right? It does count, right? It does go up by 1, but every other term is negative. So the evens are positive, the odds are negative, but at least I can figure out how many numbers there are, right? Because if you think about starting at 4 and you're counting all the way up to 24, so 24 minus 4 gives you a span of 20. Don't forget to add the first number. So there are 21 numbers. And it's okay that they alternate positive, negative. That's fine. But the fact that tells me I know there are 21 different terms, so that this k right here has to be coinciding with the 21st term, or the 21st, the 21st result of a pattern, and that pattern is counting by 2s. So I can start at 7 And since I want 21 terms, I would just add 20 of those differences. Because if you think about what we just did, since that denominator, if you just focus on the denominator, that's an arithmetic sequence. So the 21st term could be written as the first term plus 20 differences. And that first term was 7, and our difference was 2. Just like we had there. So 40 plus 7, so it's equal to 49. So K would be 49. So it's okay, that's weird. It's okay that the overall sequence isn't arithmetic, but I do know that the numerator isolated is pretty much arithmetic with an alternating sign, but the denominator is definitely arithmetic as it increases by 2.